In this physics question, we have a scenario where a skater is going down a skate ramp, and it's in the shape of a quarter circle with a radius of 5 meters, and the skater with his skateboard is a mass of 65 kilograms, and he rolls down this ramp and he has a velocity final of 9 meters per second. So if he starts at the top and he's at rest, he has 0 meters per second as his initial velocity. So this question wants us to solve for the amount of work done by the friction as a skater goes down the ramp. So what we know is that for work energy, work is equal to the change in energy in a situation. And we can further elaborate by saying work is equal to the change in the potential, the change in kinetic energy plus the change in the potential energy. And we can even further elaborate that by saying that the change in the final kinetic energy minus the initial kinetic energy plus the final potential energy minus the initial potential energy is equal to the total work done. However, in this situation, there are several terms, as you can see, that we can cancel out because they go to 0. So whenever you look at the full written out form of kinetic energy, that formula is kinetic energy is equal to 1/2 times mass times velocity squared. Well, in the final kinetic energy, we're down here. And so we know the mass is 65 kilograms, we know his velocity is 9 meters per second squared, and so, this situation is okay. However, the initial kinetic energy, whenever we're at the top, his initial velocity is 0. And so if his velocity is 0, the rest of the term is 0, so that cancels out. And that's the same thing with the potential final energy, is once he's down here, he's on the ground, and so he's at ground 0. So once you multiply by 0, so his height or his radius is at 0, and so this term cancels out. And so with that, we know that we're just left with the final kinetic energy minus the initial potential energy as our term. And so once we extend that, we have 1/2 mass times velocity final squared minus the mass times gravity times the radius of that circle. And so whenever we plug these values in, we get, for the kinetic energy final, we get 2632.5 joules, and then for the potential energy, we get 3188.25 joules. And so you subtract the kinetic minus the potential energy, or the kinetic final energy minus the initial potential energy, and you get this value. Now, the actual answer is supposed to be negative 550 joules, but I'm not exactly sure how they got that, because I've even changed this to 10, and I've changed it to 9.8 instead of 9.81, and I still got either this or a larger value. And so I'm not sure how exactly they got 550, but this is close enough for me to be satisfied with this answer. And so we know that the work of the frictional force, or the work done by friction as the skater goes down the ramp, is negative 550 or 52 joules. And we know that that's right because as he's going down the ramp, the frictional force is going in the opposite direction, or in the negative motion compared to him. And so that's how we know that it's a negative value.